Hey guys, it's Phil. Today I will be helping you with the Hubble Redshift Lab from CLEA. The image you see is from the Hubble telescope. This image revealed over 10,000 galaxies. While using a spectroscope of this image, a man named Vesto noticed that the absorption lines are strange because they are in the wrong places. He theorized that this was caused by something similar to the Doppler effect, which describes the change in the sound of an object as it moves past you, such as a car on the highway. His theory was correct. As the objects recede from us at high velocity, their light is shifted, and we call this the redshift. We will use this to complete the lab. The purpose of this lab is to measure the expansion of the universe, or the Hubble constant. The way we are going to do this is by using the redshift of several galaxies to graph the recessional velocity as a function of distance from us. Well, let's get started by opening the lab. First click File, then Login, and skip by clicking OK. Now that we are on this page, we are going to click File, and then Run. Now we are going to open the dome. Waiting. You will notice that the sky is moving, and to stop this we will turn tracking on. For this lab, we will look at 6 star fields. In each field, you will need to find one galaxy and take readings on it. You can go to any one you want, except for my example galaxy. Now that we have our first galaxy, we are going to take readings. We do this by centering the galaxy in our field of view like this. Now we will switch to the spectroscope. As you can see, there are 2 lines which represent the aperture of the spectroscope. Now what we want to do is take the reading. We do this by clicking Take Reading. And then simply click Start. We want to allow time so that it can collect lots of accurate data. Now we will click Stop. There it is. You can see that the y-axis is the light intensity. The high points are very bright, and the places where there are troughs, the light is dimmer. On the x-axis, we see angstroms, which are very small units of length. In this case, they are used to measure wavelengths of light. As you can see, we have 2 very prominent absorption lines. They are the H and K lines of calcium. They are in reverse order of size. If we click on them and center it, we get about 4,013 and about 4,050 as the length for the H line. Now that we are familiar with the lab, let's move on to the spreadsheet. So I will click Como Berenices, which is the galaxy I took my readings from, and type Como 2. The name for your galaxy can be found in the top left corner of the lab. As you can see, we have given you the absolute magnitude, and having this and the apparent magnitude from the lab, we can calculate the distance. Now let's enter the data. Enter the apparent magnitude, which is in the middle left side of your lab. For me, it is 12.55. It will automatically calculate the distance in parsecs and megaparsecs. Now, if you look back to your lab, you can get the numbers for your H and K lines. As I said, my K line was about 4,010. And you will enter it like so. And my H line was about 4,050. As we scroll over, you will notice that it has calculated both the H and K redshifts for us. For the K redshift, it is about 76, and for the H redshift, it is about 81. These numbers each represent percentages of the speed of light at which the objects are traveling away from us. As we scroll further, we will notice that it has also calculated the velocity for both the K and the H line. For the k line, it is about 5,710 kilometers a second, and the velocity of the h line is about 6,011 kilometers per second. You will also notice that the h is slightly faster, and because of this, the spreadsheet has also automatically averaged them for us. And we get a number of 5,861 kilometers a second as the average velocity for this object. For your lab, you are going to do this for 5 other stars. When you are done, Excel will automatically graph the slope for you, as shown here below, like this. It will average all of your stars and give you the line of best fit, or the Hubble constant, which describes the expansion of the universe. The inverse of this tells us how old the universe is. Well, that does it for another CLEA lab. Good luck, and get out there.